So traditional databases like relational has been the de facto database in an industry since it went mainstream in the 1990s. It was designed to provide transactional consistency across core business data, which works very well for application that typically has strict business rules. An example of this is, say, like a wire transfer between two bank accounts, and you wouldn't want the bank to mess that up. So transactional consistency ensures that a series of actions in the system are carried out completely or just not at all. And this prevents the system from ending up in an unpredictable or erroneous state. And as a result, users can trust the system to maintain its integrity, even after a lot of complicated actions. So, however, shortly after the internet went supernova in the early 2000s, developers discovered that it was getting harder to distribute data to more and more external systems. And this is because applications that use traditional database were primarily designed for transactional consistency. And transactional consistency doesn't really scale well with, especially at the internet scale. There are a few reasons why, but we can boil it down to its problem when it comes to scaling it vertically and horizontally. So transactional consistency is hard to scale up because it requires you to upgrade the resources for a single server. So like the CPU, memory, storage, network, and so on. And since it gets progressively harder and harder to increase resources for a single server, this means that there's a limit to how much it can vertically grow. And this can only be improved up to a certain point. Secondly, with a single server managing your data, it also means that there is a single point of failure. And since database is a critical piece of infrastructure, when it fails, the entire system just goes down. And lastly, it is prone to concurrency issues when there is an increased amount of transactions. This can cause like race conditions, deadlocks, and other things that just massively slows down the database. On the other hand, transactional consistency is also hard to scale out because it requires usually requires distributed action across multiple servers. And this slows due to latency and the extra round trips that is required between the servers to make sure the change can be executed consistently across all of them. And finally, transactional consistency is also prone to error because failure in any server is going to fail the entire transaction on all the servers. And so as the number of participants increases, the risk of failure just increases in a nonlinear way as well. So now that we see that transactional consistency is not easy to scale out, however, back in the days, developers continues to use it because there's just no better choice at the time. And this, along with the complexity of core business data, this started to result in databases that were just huge, monolithic, and just tightly coupled to many parts of the business. And this brings us to the rise of eventual consistency in the 2010s.